Matter, on the basis of the forces of attraction between the constituent particles, such as atoms, ions, or molecules, exist in three different physical states, namely gaseous state, liquid state, and solid state. You know that the constituent particles in gases and liquids are held together by relatively weak forces of attraction as compared to those in solids. As a consequence, they can translate randomly, rotate, and vibrate. Gases and liquids, thus, have the ability to flow and take the shape of their container. On the other hand, the constituent particles in solids are held together by strong forces of attraction. In other words, the constituent particles are closely packed. However, these particles can still vibrate about their fixed mean positions. Solids possess some characteristic properties attributed to their close packing. They have a definite shape and volume. They lack the ability to flow. They are incompressible. They are rigid. In general, the distinct properties of the three different states can be attributed to the arrangement of the constituent particles. In other words, any change in the arrangement of these constituent particles changes the physical state of a substance. In turn, the arrangement of the constituent particles in a particular substance depends upon the external conditions of temperature and pressure. For example, at 1 atmospheric pressure, water in liquid state gets converted into its solid form, ice, at 0 degrees Celsius or 273 Kelvin. Let us now understand how the molecules of water in liquid state attain the molecular arrangement of water in solid state. On cooling, the potential energy of the liquid molecules is released in the form of thermal energy. As a consequence, the space between the molecules decreases and the intermolecular forces of attraction increase. Also, the molecules lose their translator movement and rotatory movement, and they can only oscillate about their fixed mean positions. Thus, the molecules of the liquid attain the molecular arrangement of the solid. Let's take a quick look at how the structure and properties of a solid are correlated to one another. The nature of the constituent particles, the forces of attraction between them, and their arrangement together determine the structure of a particular substance. The properties of any solid substance ultimately depends on its structure. Hence, any change in the structure of a substance changes its properties. For example, the conductivity of silicon increases with the addition of impurities such as arsenic. So, a solid with the desired properties can be prepared by altering its structure. Some solid materials that were prepared for applications in various fields are superconductors, such as intercalated compounds of fullerenes, certain ceramics, synthetic biopolymers such as PHBV and PLA, and carbon nanotubes. Hence, the study of the structures of solids has immense significance in science and technology.